Okay, so here is the question for you now. All right, so this is the equation of the parabola. And again, meters equals meters plus meters plus meters. So what are the units of the 1? Where's the 1? Right here, right? The coefficient of the x squared term. So figure it out and pick one. So pause your video and figure it out. Okay, I assume you're done. Okay, so the unit of the x is meters. So this, okay, so there's a 1 here. So you got to write the 1, right? So there's the 1. So x is meters, so it's meters squared. So therefore, what has to be the units of the 1? Well, we want to get meters, so that means we get rid of one of these meters. So the units of the 1 has to be 1 over a meter. Because 1 over a meter times meter squared equals meters, which is what we want. So it's number 4, 1 over meter. All right, let's do another one. What are the units of the minus 6, the coefficient of the x term? So please pause your video and figure it out. Okay, let's see. So the x is in meters, and we want meters. So therefore, what has to be the units of x? No units, right? No units. Because we want meters, we have meters, so we just don't, it's just no units. Okay, last. What has to be the units of the 9? So pause your video and figure it out. Okay, so we want meters equals meters plus meters plus meters. So this has to be meters. So number 2 has to be meters. Okay, so you'll be doing that all semester, so make sure you know how to do it. Okay, all right, now I just want to talk a little bit about the difference between average velocity and instantaneous velocity. And remember, I'm not going to say instantaneous velocity very often. When I say the word velocity, I always mean instantaneous velocity. If I want to say average velocity, you have to say it, average velocity. And you have to write it down, average velocity. Okay, so that's super important. Okay, so that's average velocity, the displacement over the time. And velocity, or instantaneous velocity, is the displacement over time for a small delta t. That's the important thing, for a small delta t. So let's talk about this delta t, small delta t. So here's a bicycle computer. You know, it measures your speed and distance and da-da-da-da-da. So what do you just suppose delta t is for a bicycle computer? What do you just guess? I mean, I don't know, to tell you the truth. Maybe 100th of a second, maybe 1,000th of a second. I don't know, but something like that. Because they're pretty good, you know, they're pretty accurate. Okay, here's a wall clock that you see all over campus. You know, it goes like this, you know. All right, so what's delta t for a clock like that? Well, probably a second, right? Okay, now here's where we pay attention. And of course, it's chopped off again. That's all right. So here is a video camera. And let's say it takes 30 frames per second. So 30 frames per second. 30 frames per second. All right, so therefore, what's the delta t? In other words, what's the time for 1 frame? Well, you know, if it's 30 frames per second, then 1 frame, what I'm calling delta t, right? The time for 1 frame is 1 over 30 of a second, right? And actually, we're going to be using that a lot in lab this semester because we're going to be, well, we're going to be using video cameras like that takes 30 frames per second. And so we're always going to have our delta t to be 1/30th of a second. Okay, that's it. Thank you.